This lesson is Unit 2, Lesson 4, Function Notation, and the objective is students will be able to evaluate functions using function notation. In our last lesson, we talked about what a function is, and a function is a relation that has only one y value for every x value. So x can only be paired with one y. And one way that we tested a function was by using the vertical line test. Today we'll be talking about function notation, which is pretty much a way of us writing the relationship between the input and the output on any specific function. So let's start with our vocabulary. Our term is function notation, and that is a way to name a function using f of x instead of y. So right here you'll see f parentheses x close parentheses. That is pronounced f of x. So f of x is a different way for us to label something. In the past, we've done y. Instead of y, we'll use f of x. So, for example, if we had y equals 4x minus 7, instead of writing that as y, we could write it as f of x equals 4x minus 7. Part of the benefit of doing it this way is, first of all, if we have multiple equations, we can keep track of the equations because we could call one of them f of x, another one could be called g of x, we could have b of x, any letter would work. So that can help us keep track of the different functions. Another benefit to this is that it shows the input and the output. So if we were to put a 3 right here in place of x, that means 3 would be the input, whatever we have over here would be the output. So it really gives us a clear image of everything. So like I just said, you can use any letter such as G or B. So instead of f of x, it could be g of x, b of x. Another benefit, we can use it to name a line. So let's say I have these 3 different curves. I could call one of them f, one of them could be called g, and the other could be called b. That kind of helps us keep track of them and stay organized. So now that we know what function notation is, and we know that we can use any letter and we can name lines with function notation, let's go on and evaluate a function over a certain domain. So we're going to go through these steps. The function we're going to evaluate is f of x equals 4x minus 7, and the domain is 1, 2, 3, and 4. The first step is to substitute each x value into the function. And this is going to be done one at a time. So I have 4 different x values here, 1, 2, 3, and 4. I'm going to start with just 1. So every place that I see an x, instead of writing x, I'm going to write 1. So f of x is going to become f of 1 equals 4 times, instead of x, I'm going to do a 1, and minus 7. The next thing I'm going to do is go through and actually evaluate this function. Once again, this will be done one function at a time. So a place where a lot of people mess up is that they think that this f of 1 is f times 1. And they're very tempted to go in here and divide by 1 and cross out 1. But that is not correct. Remember that this f of 1 is pretty much just like y. So if this said y equals 4 times 1 minus 7, we would just do 4 times 1 is 4, 4 minus 7 is negative 3. You do the same thing. In fact, when I actually start evaluating this, I don't like to rewrite f of 1. I just write it at the beginning and at the end. So 4 times 1 gives me 4 minus 7. And 4 minus 7 is negative 3. So my answer is f of 1 equals negative 3. I have to do that for every number in the domain. So now let's go ahead and do it for 2. So we have f of 2 equals 4. Instead of x, we're going to put a 2. And then minus 7. Well, 4 times 2 is 8. And 8 minus 7 is 1. So that means that f of 2 equals 1. Now take a minute yourself and go ahead and do that for f of 3 and f of 4. So f of 3 equals 5 and f of 4 equals 9. Now that I have evaluated the function for every variable or every value in the domain, I'm going to do my last step, which is just to collect the set of outputs and write them as the range. So my domain up here was 1, 2, 3, 4. My range is going to be negative 3, 1, 5, and 9. Remember, the domain is the input, so I took 1, 2, 3, and 4, and I put them into the function. What came out was my range. So the numbers that came out of the function were negative 3, 1, 5, and 9. Let's go through one more example. For this function, we have function g instead of f, and it's g of x equals 3 to the power of x plus 1, and the domain is 0, 1, 2, and 3. My first step is to substitute each x value into the function. So let's start with the first value of 0, 3 to the power of 0 plus 1. So instead of my x here, I put a 0. Instead of my x here, I put a 0. This 0 really just tells me what I've substituted in. It's not going to do anything to the left side of our equation. So leave alone the g of 0. We know that any number to the power of 0 is 1. And we have 1 plus 1 equals 2. So g to the power of 0 equals 2. Let's switch colors and we will do our second input, which is 1. Everywhere I see an x, I'm going to input a 1. And following order of operations, we do the exponent first. 3 to the power of 1 is 3. 3 plus 1 is 4. So g of 1 equals 4. Let's move on to 2. G of 2 equals 3 to the power of 2 plus 1. G to the power of 2 is g squared. Or sorry, 3 to the power of 2 is 3 squared. So 3 times 3 is 9. 9 plus 1 is 10. So g of 2 equals 10. When 2 is the input, 10 is the output. And finally, we have g of 3 is 3 to the power of 3 plus 1. 3 to the power of 3 means 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, plus 1. 27 plus 1 is 28. So that means when my input is 3, the output is 28. G of 23 equals 28. Finally, I want to go through and I want to write my outputs as a list or as part of the range. So we start with the input of 0, the output was 2. When the input was 1, the output was 4. When the input was 2, the output was 10. And when the input was 3, the output was 28. This information could also be organized on a graph. So say I wanted to plot my points. I won't have enough room on this graph to do all of them, just a few. But where we had input of 0, output of 2, that's like going to the point 0, 2. Input's 1, the output is 4. That's going to take us up here. The input is 2, the output is 10. That's going to take us up here. You'll see we can also organize the information this way. So this is function notation. You can use function notation with any letter, so f of x, g of x, those are kind of the most common. K of x, L of x, M of x, N of x, those are all possible. And function notation is useful because it shows us the input and the output, and it also allows us to assign names to different lines. So that would be function G.